So the next aspect of statistics that we're going to look at is frequency and frequency tables. So frequency, by definition, means how often something happening, right? How often it's occurring. So a frequency table is just a table showing how often specific values occur, and it directly related to the basic statistical diagrams, which we'll be jumping into a little bit after. So here we have what we call raw data. So this is on group data. So I walk around by some people playing some sports, and this is out of 10 shots in a basketball hoop, these are the scores that they get. So it could be anything, right? This is just the raw data that I collected. It ungrouped. That's why we call it raw data. We didn't do anything with it, we just collect it, and now we're going to group it and organize it. One of the best ways to organize it is in a frequency table. And again, you're seeing the raw data that we're going to use for the frequency table. So a frequency table means, obviously, we have to have frequency, meaning how often these specific values occur. And the next heading is going to be the actual values that we have. Now, the values could have a specific name. It could be height, weight, age, scores on a test. In your question, it will be specific, and that specific name will go here along with the units if it have units. So the values we here and values we have here, and again, we don't want to have it wild and all over the place. So since we have numbers, and we're going to say how often those numbers occurred, because that's what we want to do. A frequency table, we're going to say how often the numbers occurred or whatever we're looking at. We want to do it in a structured, organized fashion. So we're going to go from the lowest number to the highest. So we have 4, and then 5, 6, 7, 8, 9. So those are the numbers we had in the raw data, and we just translating it to the table. So what we're going to do now is a different way to do the frequency. You could do a tally chart. If we was doing a tally chart, I just covering the 2 one time. A tally means you'll use strokes. That's to represent 5. Frequency means we just put in a number. So that's the difference between the tally and the frequency. Sometimes the tally will still come up. So how much 4s we have on my raw data list of numbers we have here. So I'm going to scan through. I see 1, 4. So we only have 1, 4. And if it was a tally, it would be 1 stroke. How much 5s we have on my list of values here? So I have 1, 5, 2, 5. I cross it out so I don't make a mistake and check it back. 3 5s, 4 5s. So I have 4 5s on my table, or if it was a tally, I would have put 4 strokes, right? How much 6s I have on the table? Again, I'm going to check 1, 2, 3, 4, 5 6s. And again, if it was a tally, just to show you what 5 looks like on a tally, 1, 2, 3, 4, and the 5 comes diagonal. That's how we would do it if we was doing a tally. And tallies and frequencies are a little bit related, as you see. How much 7s? 1, 2, 3 7s. How much 8s? 1, 2 8s. 1 9. And just to make sure I didn't miss out anything, if I was to add up all the numbers in my frequency, it should really total how much numbers I start off with. So 4 at 1, 5 at 5, 10 at 3, 13, 14, 15, 16. So when I add up my frequency, I had 16 numbers. So that means these are the 16 numbers that I take. Let me just double check. 2, 4, 6, 8, 10, 12, 14, 16. So I put those 16 numbers in the table. Some of the numbers repeated, but all 16 numbers are counted for. So that's how to do a frequency table. We just transfer everything to the table. It wouldn't be this simple the higher up you go in maths. So you could do different things with this information you have now. One of the main things you could do is find the mean using the table. So if I want to find the mean again, if you recall, I have to add up all the numbers and then divide by how much numbers I add up. So I need to put a new column on my table to incorporate how I'm going to add up all the numbers, because I want to use the table, right? Once I have the table, because I could have easily add up all these numbers if I had it and then divide by how much numbers I have. But when I'm doing something like a census or a larger survey, what if I have hundreds or thousands of numbers? It'll be kind of tedious to add up each one of those numbers individually. You're more likely to make a mistake, and that's where the table comes in handy, especially for larger groups of numbers. So I extended my table. I need to work on my straight lines as well, but we'll sort that out after. And I'm still going to add up the numbers, but because I have a table, I'm going to do it in an organized fashion. So what this means is I'm going to add up each number and get a total for that number one at a time. So how much 4s I have on my table? I had 1 4. So if I was to add up all the 4s on my table, it only have 1 4. So in other words, 4 by 1, 4, because it only had 1 4. Adding up the numbers individually by the amount of numbers I have. I had 4 5s, meaning I had 5, 10, 15, 20. 5, 10, 15, 20. What were my last 5? 5, 10, 15, 20. So instead of saying 5 plus 5 plus 5 plus 5, since I know I have 4 5s and I want to add up all of them, I could just say 5 by 4, and all the 5s going to add up to 20. And then I do the same thing. I have 5 6s, in other words, 6, 12, 18, 24, 30. But instead of adding them up, 6 add 6 add 6 add 6 add 6, on the table, I could just say 6 by 5 and get 30. And then I could just continue like that, because it's a pattern. 7 trees, all the 7's going to add up to 21. All the 8's going to add up to 16. All the 9's. So by the time I multiply out my table here, value by frequency, this here, when I combine all of them, I'm going to give me how much all the numbers going to add up. I just did it in an organized fashion. So all the 4's add up to 4, all the 5's add up to 20, and so on. So when I reach here, I'm going to add up all these numbers. When I add it up, I'm going to get 100. And you can double check that. And that would be the same thing if I was to add up these numbers individually here. So that's not my answer. That's just what all the numbers going to add up to. And if you remember, the formula for mean is how much all the numbers going to add up to. In this case, they're adding up to 100. Sum of all the numbers going to add up to 100. And then I divide it by how much numbers I add up. Now, the mistake students make, they're seeing 1, 2, 3, 4, 5, 6 numbers. And they're like, oh, well, I add up 6 numbers. But what I'm really doing, and you're seeing it better here, I'm really adding up these. Because remember, each one of these numbers would repeat. We had 5 6's, 3 7's, 2 8's, and a 9. Now you don't have to write this here, I'm just showing you where the numbers come from. So it really wasn't 1 2 3 4 5 6 numbers. It really was 1 4, 4 5's, 5 6's, 3 7's. So in other words, it was really 16 numbers. So these are the two numbers that you're always using for the mean. When you multiply a table and add it up, and the total frequency, I want to divide those two numbers, I'm going to get 6.25, which makes sense because your mean always have to be in between these numbers. Because if I find the averages of the numbers from 4 to 9, obviously my answer have to be between 4 and 9. If I divide this by 6, my answer going to be 16 point something, which obviously is not even in between these. And you'll see it better when we look at our next example in a little while.